Hey guys, question is the compressibility factor for an ideal gas is, हमसे पूछा गया कि आइडियल गैस के लिए compressibility factor क्या होता है। compressibility factor होता है Z equals to PV by RT. For an ideal gas we can write that PV equals to RT. This is for 1 mole of an gas. यहाँ पे Z की वैल्यू आएगी PV by RT. यहाँ पे PV की वैल्यू RT होती है, so Z will be 1 for an ideal gas. compressibility factor 1 आएगा। यहाँ पे करेक्ट ऑप्शन होगा ऑप्शन बी, हमारा आंसर होगा ऑप्शन बी। compressibility factor का सिग्निफिकेंस होता है कि ये बताता है हमें अबाउट द compressibility of the gas. अगर Z is greater than 1, इसका मतलब ये आया कि gas is less compressible than ideal gas, क्योंकि for same P and T इसका वॉल्यूम ज़्यादा होगा। तो वॉल्यूम ज़्यादा होगा तो इसका मतलब ये होगा कि इसकी कंप्रेसिबिलिटी कम होगी। और अगर Z इज लेस देन 1, इसका मतलब ये हुआ कि वॉल्यूम कम होगी। वॉल्यूम कम होगी तो कंप्रेसिबिलिटी ज़्यादा होगी। आई होप आपको समझ में आया होगा इसका सिग्निफिकेंस। दिस इज हाईली सिग्निफिकेंट फॉर अ रियल गैस एंड इट टेल्स अबाउट द डेविएशन ऑफ अ रियल गैस फ्रॉम द ideal behavior.
Hello and welcome. The question is ratio between root mean square speed of H2 at 50 Kelvin and that of O2 at 800 Kelvin. So VRMS is square root of 3RT upon M. So V of H2 and V of O2 would be equals to the temperature 50 upon the molecular weight of H2. This is 2 and the temperature 800 and the molecular weight of O2 is 32. So this is 16 and this is 2, this is 1. So this ratio is 1. Thank you. The question is at constant volume for a fixed number of moles of a gas, the pressure of gas increases with increase in rise in temperature. Yeah. So pressure increases when you increases the temperature. This is because pressure is just because of collision of the gas molecules. Okay. With the walls of the cylinder. So when you are increasing the temperature, the V average velocity is also increasing. So now the molecule has more velocity, so it will collide with more speed. So pressure will increase. So the increase in average molecular speed, your pressure will increases. Now the second thing is decrease in rate of collision. No, the rate will increase, not decrease. So this is false. Increase in molecular attraction. No, because molecules are moving so rapidly that there is no molecular attraction, and molecular attraction is 0 in case of ideal gas. So molecular attraction will not increase, it in fact decrease, and decrease in mean free path. It is not relevant with the rise of the pressure. So this is because of increase in average molecular speed. Thank you.
Hello students. The question says that according to kinetic theory of gases, the pressure of a gas is expressed as P is equal to 1 by 3 rho C square, where rho is density of gas and C square is the mean square speed of gas molecules. Using this relation, show that the mean kinetic energy of gas is directly proportional to the absolute temperature. So first of all, let us write the expression given in the question. It is given as pressure is P is equal to 1 upon 3 rho C square. Now basically we have to obtain this expression in terms of temperature. So as we know that density is given by the relation of mass upon volume. Now on transferring the volume to the LHS, we will get the expression as PV is equal to 1 upon 3 mc square. Now as we know, by ideal gas, now we will take into assumption that number of moles are 1. So PV is equal to nRT, where number of moles we have taken it to be as 1. So it becomes PV is equal to RT. So the expression on the left hand side will be modified as RT is equal to 1 by 3 mc square. Now in question we need to obtain kinetic energies. Now how to obtain kinetic energy? Let us see. Basically, if we use this expression of RT is equal to, now let us divide it by half and multiply it by 2 mc square. Now let us transfer 3 and 2 onto the LHS side. It becomes 3 by 2 RT is equal to half mc square, and half into m, speed square, is basically kinetic energy. So kinetic energy is half mc square. So let us label this as equation number 1. So this equation 1 will now become kinetic energy is equal to 3 by 2 R into T, where 3 is constant, R is a gas constant, and your 2 is also a constant. So we can say that kinetic energy is some constant times T, or we can say that kinetic energy is proportional to the temperature. So as in the question it is being said that show that your kinetic energy is directly proportional to the absolute temperature. So in the solution we have shown that, you can see over here, that kinetic energy is directly proportional to the temperature of the gas. So friends, I hope the solution is clear. Thank you very much.
The question is, the rate of diffusion of methane at a given temperature is twice that of a gas X. So the molecular weight of X is, and these are the options. So according to Graham's law, at a given temperature, the rate of diffusion of a gas, it is inversely proportional to the square root of the molecular weight of the gas. So from here we can write that the rate of diffusion of CH4 by the rate of diffusion of the gas X, it is equal to under root of the molecular weight of X by the molecular weight of CH4. So in the question it is given that the rate of diffusion of methane, which is the rate of diffusion of methane at a given temperature, is twice that of the gas X, which means the rate of diffusion of X. And we have to calculate this molecular weight of X. So if we calculate the molecular weight of CH4, so it will be the atomic weight of carbon, it is 12, plus of hydrogen, it is 1, and there are 4 hydrogen atoms, so into 4. So it will be 16U. So now if we put these values here. So it will be twice of Rx by Rx is equals to under root of molecular weight of X divided by 16. So from here this Rx will get cancelled out and it will be 2 is equals to under root of mx by 16. So now if we square both the sides, then it will be 4 is equals to mx upon 16. So this molecular weight of X will come out to be 64U. So our correct option will be option 1.